Hi, this is Mick Elliott of Electronic Specifier. I am on the NXP Semiconductor stand at Electronica with Brian Carlson, and we're here to talk about a new series of microcontrollers that NXP have recently launched. Brian, over to you.
Oh, thank you. Thank you. Thanks for coming to the NXP booth. We actually introduced a new processor or microcontroller, the S32K39. I think we all know electrification is a booming business right now. If you look at the car makers, they're all investing heavily into, and their whole fleet's going electrified. You know, 20 billion, 30 billion type investments. It's huge investments. And what we did is we took our S32K family, extended it to support this next wave of EVs. EVs have to be able to range across their fleet from low end to high end. There's some unique requirements on performance. EV market, the technology is changing so fast, we need to be able to enable it. At the end of the day, it comes down to three things. It's about enabling a better driving experience, enabling these new technologies that allow us to increase that performance, reduce the costs, and cost actually at the bottom line is really, really important because everyone wants to get the cost down below ICE that we have today. So what we introduced is we took a approach that allows us to not only address the performance to address future technologies, but we also integrated a lot of analog and capabilities that allow us to reduce the cost. At the same time, high performance and high precision that allows us to give a better driving experience. So I'll start with the S32K39. The S32K39 is a microcontroller that can support two electric motors at the same time. What's unique about it is has not only ARM processors, but it has dedicated co-processors for motor control, and that gives it the high performance. In addition to that, it also has high resolution, high precision to control those motors, which gives a better driving experience, a better, smoother experience, and a more efficient driving experience. And we do that through high resolution pulse width modulation that drives a gate driver. And what that's doing is taking that high voltage, usually 400, 800 volts of battery, converting that to AC three-phase that moves that motor. We have a control loop where we're actually monitoring that position of the motor at all times. We actually remove a part that typically assists to take that signal and provide information, the position and the speed. We remove that part, we integrate that capability directly in this device, so part of that cost reduction. So all of this works together to provide the ability to support the future technologies like silicon carbide, gallium nitride, which are the up and coming technologies for switching that give a tremendous amount of increase in efficiency, because the name of the game is how far can my electric vehicle go, and we're helping to address that. So we're improving the driver experience, we're enabling these new technologies to make these EVs better, lighter, smaller, and we're providing a cost reduction path for the car makers.
Just to be clear, it also supports IGBT as well.
Oh, good question. Yes, so we do today's IGBT, silicon IGBT, as well as the SiC, which is starting to emerge, and gallium nitride as that starts to become more in the next few years. So we're already future-proof. One thing I forgot to mention is this is ASIL D. It is based on the highest level of functional safety with a solid software foundation supporting ISO 21434, and it's upgradable through over-the-air update. I like to call this the software-defined motor because we have the ability to do amazing updates and improve the efficiency of that motor over time with the S32K39.
Well, it addresses what are known as the vehicle zonal architectures. Can you just talk through that a minute?
Yeah, that's a good point. And actually, let me tie that into our announcement. I talked to you at Embedded World about the S32Z, S32E. S32E is like the brain of the whole EV, and we actually show how that fits in here. Here, S32E can be the whole brain and control, tell the motor controller, the S32K39, what needs to be done. So if someone presses the brake, someone's accelerating, emergency braking kicks in, you have traffic assist, anything that's affecting the motion, you need to control the motors. So that S32E in a zonal architecture could command this, which is within the motor, and control the vehicle. And the beauty of that, it uses TSN Ethernet that allows us to be able to do deterministic high quality communication across the vehicle, and we can support 1, 2, 3, or 4 motors, and that's really important. As OEMs are going to do fleets, their whole lineup of EVs, they want to have maybe a an entry vehicle that's a single motor, mid-level that's a dual motor, 3-level for it's a high-performance version, and then a 4-motor for off-road trucks and those for better driving experiences. So the nice thing about those two working together is that we can scale to support 1 to 4 motors, 2 each with each of those processors.
Because I know this is about inverter control initially, but it does support other applications in the car.
That's a great point. I almost forgot that we're announcing the S32K39, but we kind of put a little bullet that we also offer it without the motor control coprocessors, and we call that the S32K37. It's a great processor for high performance battery management, also for power conversion, for onboard charging, any type of application vehicle control. So it gives our customers not only a great platform with motor control for the K39, but the lower cost K37 that doesn't have the motor control, that can be used for other modern electrification applications.
And the product's available now?
Yes, so we started delivering this to early customers. We call them alpha customers in June timeframe this summer. We are on track. This is in today North America, Europe, a lot in China. We have some very active customers in China. It's moving very quickly there. This is on track for production silicon at the end of 23. We'll start to see vehicles first quarter of 2024.
Okay, Brian Carlson, thank you very much.
Thank you. Thank you for stopping.